So Pythagoras is a place where we use squares, and we often need to find lengths of the sides, which means we need to square root, because remember that square rooting is taking an area and finding the side length. So when we use Pythagoras, we often end up with radicals. So we can end up with some mixed radicals here. So when I do my Pythagoras, I know that this square here, okay, 15 squared is 225. And this squared here, okay, this ends up being 100, which is 10 squared. We know that these two areas, if we subtract these two areas, we should end up with this area here, this square area. So this square area must be just slightly bigger and 125 squares. Okay, so to show the equation for this, we did c squared minus b squared c squared minus b squared equals a squared. Okay, so just color code that so the a squared is in red. But remember that when we do Pythagoras, we're really finding area. But what we want is side length. To go from the square area to side length, I'm going to square root, and I'm going to get 125 square root as my side length of that side. Now we need to write that as a mixed radical, which means then when I have 125, I need to find my perfect square factor. It's going to be 25 times 5. Okay, that square root of 25 becomes 5, and I'm left inside the radical is at extra 5. So 5 root 5 works out to be the exact value. So when we talk about exact values, we don't want decimals. Okay, we don't want to be using our calculators to get decimal values here. So we'll do the same thing here. We know that the big side squared. Okay, the 9 is the longest side, so we're going to need to take away the square of the next side. So we know that 9 squared minus 7 squared should be equal to, we'll call that side A, we'll call that A squared. Okay, so working this out, 81 minus an area of 49 equals A squared. Okay, so this works out to be 32 is equal to the length A squared. Square rooting that, we do get plus minus, but since we want the side length, we're just going to use the principal square root, which is the positive value, and we get square root of 32. Okay, square root of 32 can be simplified, because square root 32 can be rewritten in a number of different ways, because it's perfect square divisor of 4, but there's also perfect square divisor of 16, which makes it slightly easier to work out. So the square root of 16 works out to be 4, and inside the square root, we're just left with the 2 inside the square root. So 4 root 2 is the exact value of that length A. So here we have c squares, or c, and this one, in this case, c is the longest side, so we're going to add the area from side 34 plus the square area from side 32, and that's going to be equal to the big square from the side length of c.